Hello everyone, myself Kunal, and today we will be solving our problem of the day. And the name of the question is union of two sorted arrays with distinct elements. So let's see what we have. In the question, we have given two sorted arrays A and B, and each array is containing distinct elements. So our task is to return the elements in the union of the two sorted arrays. So we have given two arrays. Both arrays are given in a sorted order, and we have to return the union of these two arrays in the sorted order itself. So let's see what's a union, and let's understand it with the help of an example. So here's our example. We have given two arrays A and B. The array A is 1, 2, 3, 4, 5, and B is 1, 2, 3, 6, 7. As you can see, 1, 2, 3 and 1, 2, 3 is common in both the arrays. What will be my union will be looking like? My union will look something like this: 1, 2, 3, 4, 5, 6, 7. As my union contains only distinct elements that are appearing in either of the arrays, it won't be containing multiple elements as 1, 2, and 3 are appearing in both the arrays. It is containing them only once. Let's understand it with the help of a Venn diagram. Here it is our array A. It contains 1, 2, 3, 4, 5. And here's our array B. It contains 1, 2, 3, 6, 7. How my union will look like? My union will look something like this: 1, 2, 3, 4, 5, 6, 7. Right? As 1, 2, and 3 is common for both the arrays, it only once. It is not taking duplicate elements, right? So this is my array. So this is my union. Now we have understood what is the union. So let's understand how can we find the union of two sorted arrays. So let's see the approach. In the approach, what we can do, we can firstly use hash set. So what does hash set do? Hash set stores all the elements that are being provided to it in a distinct and unique manner, right? If we like stores 1, 2, 2, 3, 3, 4, 5 in the hash set, my hash set will be containing 1, 2, 3, 4, 5, as it will be ignoring the multiple insertion in it, and it will be storing only distinct elements. First thing we can do is we can store all the elements that we have in both the arrays in a hash set. Firstly, we will be storing like elements we have in the array A, and then we will be storing the elements we have in the array B in the set, and after that I'll be returning the elements of the set as it will be equal to the union of these two arrays. What we will do with doing here, as we have to return the arrays in a ordered manner, in a sorted manner, right? As we have to return the elements in a sorted manner, we will be using a ordered set, but there's a drawback of using ordered set: the insertion time complexity. The insertion time complexity in an ordered set is O of log n. It takes O of log n time complexity to insert a single element in the ordered set. If we will be creating an ordered set, the size of the set will be O of n plus m. If we consider n as the size of our array A and m as the size of our array B, this will be the size of our ordered set. And to store each element, we will be running a loop for n plus m times. One loop we will be running for n, and another loop we will be running for m. So time complexity will be order of n plus m, but for each element there will be some time that will be taken for the insertion. For insertion, it will be taking O of log of size of set. Size of set is n plus m, O of log of n plus m. This time complexity will be taken by our code if we use this ordered set, and the space complexity will be O of n plus m, which is equal to the maximum size of the set. So we can surely optimize this time complexity, as the arrays that will be given to us will be in a sorted manner. So let's see a more optimized approach. Let's here we have two examples, and we will be using merge. The similar merge function we use is in the merge sort to find the union of these two arrays, right? We will be creating two pointers, like my one pointer will be standing here and other pointing will be standing here, and we will be traversing both of these arrays, and by traversing one by one we will be checking which element is smaller, and we will be pushing the smaller element in our final answer array, and then we will be moving our pointer to the next of it. Let's see. Let's we have a array named as answer. and we have two pointers here. Let's call it J and let's call it I. Initially I is pointing at 3 and my J is pointing at 4. So I'll compare both the elements I and J. So the I has value 3 and A of J has value 4. So I'll be pushing the smaller element. So I'll push 3 here and I'll increment my I. So my I is pushing at 4, pointing at 4, and J is pointing at 4 also. When this condition occurs, I'll be pushing any one of them. Let's say if I push B of I, I'll be incrementing my B, and I'll also be incrementing my J because J and I was same. So here I have 5 and my I is pointing on 6. So I'll be pushing my J. Here I have 5 because 5 is smaller than 6. So I'll be pushing my J and I'll be incrementing my J. Now my J is pointing at 6 and my I is pointing at 6. So I'll be pushing any one of them and I'll be incrementing both of them. Now my I is pointing at 7. J is pointing at 8. Now I'll be pushing 7 because 7 is smaller than 8. Now I'll be incrementing both of them. As any one of these pointers goes out of bound, like we will be having some condition, some while condition. If while b is less than m and a is less than n, we can name anything to the pointer. We are assuming that m and n are the sizes of the respective arrays. If that happens, we will come out of loop, and outside loop we will be checking if my j pointer is less than the size of the array a. If it is not, then we will be pushing rest of the elements. So here was my j, so we will push rest of the element, which is 8, 9 and 10. And similarly we will be checking whether my I is less than the size of this array B or not. Yes, it is not less than the size of the array, so all the elements of the B has been pushed in the final answer. And after that we will be getting our final union that was required. Let's jump to the code. Here in the code, as the parameter, I am getting two arrays. These both arrays will be sorted. So I have created a result array and I have created the size, two variables for the size of both the arrays. And similarly, I have created two pointers here, I and j. I'm running a while loop until my I is less than n and j is less than m. And in the first condition, if I'm checking if if a of I is less than b of j, if it is lesser, I'm pushing it in my result array and I'm incrementing my I. If this condition doesn't fulfill, I'm checking another condition. If array of I is greater than b of j, if this happens, then I'll be pushing my b of j because it will be smaller. I have pushed my b of j and I'm incrementing my j pointer. Else, if both of these condition doesn't fulfill, this means that my both the elements are equal, like they are pointing at the same element. So in that case, I'll push any of the elements. Like here I'm pushing array of I and I'll be incrementing both of them. Here I have incremented I and here I have incremented j, and outside this loop I'll be checking if I have reached to the end of the array or not. Here I'm checking if I is less than n. If I is less than n, then there's still some element left in the array A which are not inserted in my final array. So I'll be inserting those elements in the final array until my I reaches to n. And I have done the similar thing for j. I'm checking whether j is less than m, which is the size of array B. If j is less than m, I'm inserting all the elements that are left until it becomes equal to m. If it becomes equal to m, that means all the elements that I have has been inserted. And at the end, I am returning my result, which will be containing all the elements that needs to be present in the union of my final answer, right? So at the end, I'll be pushing. So at the end, I'll be returning this res, which is containing the union of both the arrays that I had. Now the question has been completed. I hope you all understood it. Thank you for watching, everyone.